Hi, my name is Bo. I'm going to introduce some PC touchpad projects that we have been working on with new technologies. The first one that we're trying to introduce is a ForcePad feature to let user understand when there's a system event comes up, we can notify the user at their fingertips. For example, you're doing your day-to-day work, and then all of a sudden there's a low battery warning comes up, and then it will nudge your finger with a specific haptics feedback. And that feedback can also be configurable on the strength as well as the frequency. So that way it's very direct to the user interactions.
You call it haptic cue?
Yes.
All right. So there's feedback based on what's happening, like notification in the feedback.
Yes.
And it can give strong feedback, slow feedback.
Yes. The strength can go anywhere from 3G to 8G based on the product the feature is implemented. And then we can also change the frequency of how long the notification is sending. It's also user configurable.
So the user don't like it so much, they can have less of it, or they want more of it.
They can tune it down. They can remove certain notifications. So all of that, I think it's freedom for the user.
Does the haptic feedback remove any efficiency of the touchpad, or it doesn't change impact?
No. So if you are using the touchpad for day-to-day click events, that haptics will still be dominant as the primary. And then while you are just navigating without click, and then those haptics waveforms will be triggered.
And here's a different notification: incoming email.
Correct.
The priority message, meeting event, low battery.
Yeah.
Stand up reminder.
Yep.
All kinds.
Yep.
All right. And what else do you show here?
Let's move on to the next. For this particular demo, it's a ForcePad that has our capacitive force sensor integrated. So with the force data as well as the touch data, we can help differentiate certain 3D gestures, such as knock-knock. And the way how we do this is to do data collection and then training in the background. And then we can port the model into the firmware, so it will be able to differentiate different contexts. And the main thing that we're trying to solve the problem is force triggers. So with this gesture, we can differentiate from knock-knock from tapping. So only knock-knock will be able to trigger the feature.
Is there other things than knocking?
So far we're doing the single knock, double knock, but the limit is still in the research process where we can define more 2-finger, 3-finger additional.
The whole hand or something?
Even with a hammer, that's all possibilities we're exploring. And the next one is we call the Forcelite. It's a mechanical click anywhere design, where we try to enable similar features like ForcePad. You can click in different regions of the touchpad. So the main benefit of that is when you are doing day-to-day typing work, you don't have to look at your touchpad to know where to click on your touchpad. So that provides additional convenience to the user. And we also have a fingerprint demo here based on matcher integration.
Has there been some improvements in the speed of fingerprint learning since the last time? You do better and better?
So this AI model we're trying to train is to solve a problem who has been troubling some users in the modern days where the fingerprint sensor becomes smaller and smaller. So it will require a lot of touches to complete the enrollment process in order to get a satisfactory acceptance rate. And the algorithm that we're trying to improve is during the enrollment, we're trying to stitch the image together to understand the overall finger coverage, so that until a criteria is met, instead of 14 touches to complete the enrollment, we can complete the enrollment at 8 touches with the same recognition rate.
All right, 8 touches.
That will
Can you
help
do even
the
less
first-time
in the
user.
future?
And the next step we're working on is to improve the identification rate for people who have difficult fingers, like women or kids who have very light ridges, so their signal is low, the image quality is poor. Instead of using a fixed threshold acceptance criteria, we adjust the criteria dynamically based on the finger characteristics during the enrollment. So that will help addressing those users who have difficult time using fingerprints.
And why is it called quantum?
Quantum is a way how our internal algorithm is trained, basically.
You use a quantum computer to train it?
Eventually we will.
Okay. Because you need more and more security in the future when this security is going to change in the future.
Yes, so we're actually working on some future design of the chip to solve the post-quantum issues.